between these two multiplicatively, not additively. With linear and quadratic modeling, we did subtractions between the y's. We're going to look at divisions between the y's, or multiplications. So how did we get from 289 to 132? Roughly, we divided by 2. Watch this, watch this. If you take equals this divided by that, ish, 50%, it's 0.46. Now, if I drag that formula down, look what happens. Look, look. Now, it starts getting noisier towards the bottom because there's fewer numbers towards the bottom, but those numbers are hovering around 50%. Roughly 50% of the ones above. It's going to start getting noisy down here because there's so few things left. But that's what the model predicts. If you average these rates, you get the 53% from our model. That's why when you said average, Aaron, I love that. It's the average rate of decay, or in this case, not decay, but maintenance. It's 50%. You lose 50%, and 50% keep going. That's kind of what you're getting at, right?
So you would divide the next one line by the.
That's what I did when I dragged the formula down. This divided by that is that.
Okay.
That divided by that is that. Okay. Exactly.
And so it would never stop.
No, theoretically speaking, that's why we have to stop when we hit 0. You see what happens? We have to stop when we hit 0, but theoretically, it just keeps getting smaller and smaller and smaller. There's an old paradox. We'll tell you the paradox, and we'll come back to the cards. If I drop this marker, it will never hit the ground.
Yeah, right. It'll bounce back up.
Shh. Because think about it. In order for it to hit the ground, it first has to cover half the distance, correct? And then it has to cover half the remaining distance. And then it has to cover half the remaining distance. And then it has to cover half the remaining distance. And then it has to cover half the remaining distance. And then it has to cover... You guys, some of you guys are so good, you're tilting down the lip. So it has to keep covering half the distance, right? But it's cruel. But it never gets there. Because you keep taking half the distance, but that distance is still positive. Half of a positive is still positive. It's never 0, is it? Of course, and go.
Can you use that as a defense for running stop sign?
Yes, you can. Poorly, though. I didn't use that one, and here's why. Because as we all know, you drop the damn pen, hits the damn ground, and bounces back up. So the idea is, now tell me if this is the kind of thing 105 will want to look at. There's a mathematical connection. It's called the paradox of, it's called Zeno's paradox, I think it's called. When you drop the pen, it can never hit the ground, but it does hit the ground. So mathematically, you can prove why it doesn't, but physically it does. And there's a connection between those two that involves a little tiny bit of calculus. You guys did a little tiny bit of calculus in here already. I know I told you that, right? Last week, I think you did. Would you want to do a little bit more in 105? Michelle's like, no, yes. Yeah. Maybe. Think about that one. I'm not getting that overwhelming yes that we got with similar triangles with the eyebrow on the roof. Think about that. Mathematically, you can prove that the sum of those halves goes to the whole, even though there's always a little bit left. Zeno's paradox. Fun stuff. But yes, the idea is it never will touch, but physically it's constrained by the fact that eventually somebody's going to flip heads. That Rodolfo, I think it was in this class, he got to 9, and then he flipped heads. So eventually, even a person that flips 20, 30, 40 tails in a row is going to get heads eventually, although the mathematical model allows for the possibility of infinite flips. Fair? Infinity is a hard thing to grasp. It really is. Have you ever heard the infinite monkeys theorem? If you put an infinite number of monkeys in a room and give them each a typewriter and let them just pound away like monkeys, eventually you'll get the complete works of William Shakespeare. Exactly. Randomly. Because, randomly, eventually, one of those monkeys is going to type in order the complete works of William Shakespeare. I mean, it has to happen. That's how big infinity is. Right? Infinity is that large. And think about it this way. A lot of those monkeys are going to get within one letter of the complete works. Wherefore out there, O Romei? You know, we're going to get one letter away and then screw up a whole bunch of them. Wherefore out there, O Romeu? Wherefore out there, O Romette? You know, you're going to get a lot of those. But infinity's too big to think about in that respect. But one of them will flip a coin. And he started flipping on Wednesday and is still flipping right now. That's why that tail goes off like that forever. That was a lot of stuff in one class. Let's take 5. I took you a 5 over there. You guys ask great questions. You really